practical number third. Now the first two practicals, they were like easy, where you were learning the basic concepts of how you will be installing the libraries and how you can access some sensors, like camera is a sensor, so how you can access it using Raspberry Pi, and how you can tune between Raspberry Pi cameras and USB camera. The practical number third is something, uh, the concepts that you have learned in computer vision, that you must have learned some concepts of like background subtraction in computer vision and all. So we will be using those algorithms. Now the scope of this video is not explaining those algorithms. The scope of this practical is how to use them for our like practicals. So we'll be seeing that into this like video. So firstly, the practical is creating a bird feed monitor. So when we are saying we all the surveillance scenarios, like where we need some kind of security, uh, like when there will be a camera is recording continuous feed of our videos, okay, and then we need to detect something, okay. We so we are in this practicals, normally we are not using deep learning algorithm, we are using the computer vision algorithms. And that will be using a, that is, you can say, background subtractions. So background subtractions algorithm, there are several background subtraction algorithm in OpenCV, so we'll be using them. So background subtraction algorithm, they will do what, when suppose there is a camera and the camera is recording continuously frames. When suppose an example can be, you want to do some kind of wildlife photography, right? So it is very difficult to record some video. It is very difficult to record or get that perfect frame of that animal, right? Because when the animal is present, by the time we will reach to our lens, by the time we will click on the button, the animal will be gone, right? So what we are doing, we are using some Raspberry Pi camera, and the Raspberry Pi is continuously uh, recording the videos. But what we want to do is, we want to detect that specific animal, we want to record that and keep them into a smaller frames, okay. Means what we want to do is, like, instead of continuously we will be recording, like the video is getting recorded for 24/7, but we want key events from it, like key events of the birds, or you can say key events of some animals. You can use this same practicals for some scenarios, like in video surveillance, key event of some humans, like those who are coming inside your house or going outside your house. So you want that key events. So for that we need some kind of background subtraction algorithm. So why we need background subtraction algorithm is like, because and practically the frames are static, right? The image frames are static. So what we want is, we want whether there is any kind of motion or not. If there is some kind of motion, we want to capture that, what kind of object is creating that motion, right? So that is the reason we are, what we need to understand in this practical. So we will not be going into the depth of the that is background subtraction algorithm. That's a very different, that is a different scope, I think. So we will not be discussing them, we will be seeing how to use them in our session. Because in this practical is not that easy. There are so many concepts that you need to understand. There will be so many things we will be using newly in them, because that's how we are going to build up, like in the future practicals, okay. So we will be now you can do this practicals into you can run this practicals like on a live webcam. You need to have a live webcam, and the webcam will be continuously recording some kind of feed. And then if there is some kind of bird, the bird will come, and suppose the bird is uh, eating something. So the because we are using a this background subtraction algorithm, the background subtraction algorithm will know that there's some kind of motion, and that particular frames will be captured, and it will be recorded and stored inside your. So there is a mechanism of how we are calling it as a buffer, right? So we there is a disk, like a buffer. So when we what kind of events we need, so we need a events like when there will be a bird only at that time you capture those frames or take a snapshot of them and store inside the buffer. So suppose there is a video of 2 3 hours, so there will be some empty frames initially, and the bird will come, and then the bird is feeding, and we want to take the snapshot of those when the bird is feeding, and we need to store them inside a buffer. And then again, when the bird is gone, we don't want to record those empty frames, right? We just need the important information like some bird or squirrel or something like that, right? So that's what we are going to do in this video. Okay, so let's see. So your outputs will be looking like this. So when we are using a normal so now the background subtraction algorithm, they are not that pretty good, because just they are not deep learning algorithms, right? So they are image processing techniques that are being combined with some kind of visionary algorithms, and based on that we are doing tuning the parameters of those algorithm to get the best results. So when we are using a raw when we use a raw kind of segmentation mask, you can see a raw segmentation marks of a bird will look like this. But now in this mask is kind of a completely raw. There is no, you cannot like define where is the bird inside that. So there is some kind of mechanism that we will be doing. There are some parameters that we need to tune, that's erode function and something called as a dilation in the kernel. Okay, that's what we are doing in computer vision second chapter. You must have learned there is something called as convolution, right? Or kernel function kernels that we are using for uh, passing on to those image frames. And also that's what we are using over here, and we will be getting results like this. And then from those results we are capturing the motion in the image, okay, where the motion is actually. So let's see how our project repository is. So again we need VNC viewer. So let's see what is there in our repository. So practical number 3. So in the repository we can see there are some folders, right? So firstly you need to understand what is there in this folders. So there is a config file, then there is a output gmg, and there is up to output mog, then there is a pyc, and then there is a program code, right? And then there is a video. Okay, let's see what is this video is all about. Okay, so we can see there are some empty frames, and then the bird is coming, and then there's a second bird is coming, right? They are feeding. Then there are again empty frames in the video, right? So what we want to do is we want to create we want to use this background subtraction algorithm just to record this events when the birds are there and when the birds are feeding it, right? Because we need to monitor those things, right? Now similar the concept can be, we can use the same program we can use for humans, right? Where we need to detect the humans when we need to monitor the humans. Okay, and just we need to get those snapshots when the birds are there in this scenario. Okay, and we need to create a new video from this. So now the original video, if we are saying that it's of 10 minutes, we want to get the key snapshot of the birds, and maybe the video will be of a smaller size, right? So let's see. So firstly there are some this JSON files, and why we need this JSON file is that it's a best way to, as we have seen in last time, there was something called as argpass parameter we have used to give some additional parameters to the code, right? So you can use a .py file and XML file. There are different forms in which you can give additional parameters to the code. So in this one I'm using JSON file, and then there is something called as output, in which the image snapshots are stored, and output emoji means when we are detecting the motion, the files are stored over here. And then there is something called as pyc. Now this is we are taking a reference from your reference book, that is PyImageSource. And this clip writer is an utility function. Utility function means when we are recording the videos, so from that videos we want to just take a smaller the key snapshot, only that particular set of frames we want to extract, right? So for that we need this helper. It will be key clip writer will be used as a helper function which will extract those frame and which will write those frames in the form of a video. Then there is something called as utilities. So first file that we will be seeing, or to understand, we need to understand this file is conf py. So let's first run this code and see how it works, and then we will go back and investigate what is there in that code, and in that manner it will be much more better for you to understand, right? So let's go on terminal. So we already know it's Python PIRD py. So let's see what kind of parameters we are using. So I'm writing here as conf, right? So now it's visible. Yeah. So we are passing as conf, and then there are certain parameters that we need to pass. So initially what we are doing is we will be passing the uh, we are not gonna we have a in our folder we have a file that is a video, right? And we want to use this algorithm on that video, and let's then see the results, right? What we are saying that python bird, this is our main file, and then we are saying we are giving a parameters, that is argument passer we are giving, right? And then we are saying config. This is really important for you to understand, because so in argpass, now instead of giving all those parameters, what I'm saying, go in this mmog.json file and take all the parameters that are defined in that and use those parameters for my code. And where we are supposed to apply is there is something called as a video. We are again giving a parameter here, and then we are saying there is a video file, please use this on that video file. Okay, and then just press enter, and let's see. Okay, why this is not running is because we just want to start our we are not inside our work on py3, I think so, cv4, just enter. So now we are in our, so why we got this error, because we are not we are executing this outside in our master program, and we have not installed the libraries in the master program, so that is the reason it has given us an error. So yeah, so let's press enter and let's see if it works. So we can see that the frames are running here, right? Okay, so this is what is our output, right? So we can see when the bird is coming, there is a rectangular box is drawn on top of that, and then there is a circular frame is coming, right? See, whenever there is any kind of motion, the algorithm is working, right? So you can see that when there are multiple parts, actually this algorithm is failing, because just a normal background subtraction algorithms, and I have already mentioned that background subtraction algorithms are not that pretty good, right? but in normally in lightweight devices, like in lightweight devices like Raspberry Pi or no Node MCU, or for Jetson, we use the lightweight background subtraction algorithm. But normally we can use a state of the art deep learning methods also. We will see those methods in the future practicals, how to use them. So but in this you can see that the background subtraction is doing not bad job, but not very good, because there are so many like false results in this, right? So what we want to do is, from this entire video, we just want to get we just want to get the snapshot of the birds when there are birds in this frame. Okay, so that's what we want. So let's stop this and see what we have here. Okay, so we can see the snapshots are taken when there are birds inside this videos. When there are birds, the snapshots are taken. Okay, that's how we ran our code, and we were able to see that the key important snapshots are being stored inside this folder, right? We have seen the snapshots. So now we need to see what's there in the code. Firstly, let's see in the config file we have given this as a parameter, that is emoji JSON, and let's see what is there in this code. And then let's see in the, this is the pyc is a helper handler function that we are using here. And in the utilities there is something called as conf.py. Just click on that and let's see how this code is helping. So what we are doing is uh, we are using this two parameter here, and we are saying we are importing these two packages, that is json.minify. Why we are writing this json.minify? It means that when we are importing the file of JSON, please ignore the, can say, comment, right? So there are some comments inside this file, right? And we don't want those comments, so please ignore them. We just need this thing. So now why I'm using the JSON file is that the representation of the JSON file is in the form, similar form of, like in Python we have a key and a value pair, like a dictionary, right? So that is the reason I'm using JSON, because it's really helpful. And these are the parameters that we are giving. So what we are saying that in the JSON file, so from json.minify, you know that what is the meaning, why we are using json.minify. So it means what? Please remove this comments and just give us only this the key and the value pair. And then we are giving one class as confidence, and we are saying, come on, just load this file which is there, and that conf read this file and give us this parameters. Okay, so we have defined there, so there are certain parameters like a pi camera, so the indicate whether the pi camera should be used or not. You can indicate we don't want it, so we can just keep it false. So then there are some background subtractors. So the background subtractor we are using for the, like when we ran the code, the background subtractor we used was emoji. So there are different types of background subtractor, and you can just play with them, just change the values and see which one is giving you the better results here. Okay, so CNT, GMG, MOG, and this all the background subtractors that are available in OpenCV, but I'm using emoji. And then these are the maximum size and the iteration of the root function. I told you that when we create the mask of the image, what we are doing is, then we are performing some kind of dilation, and a root function we are using to get a good mask. Okay, if the mask is not good, what happens is your video or the video frames will also, the video frames will not be good. Okay, that's what we are doing here. We are providing this kernel and the iteration, that for which how many iteration we want to perform it. The minimum radius for the foreground we are giving it as 80 here. And the buffer size we want. Means we are saying that the clip writer should at least take 50 minimum. There should be a 50 frames, and then only we will be creating a video from it. So when your video is continuously running for at least for 50, and the buffer is full, there are 50 frames, then only we will be the codec we are using is mpgp. So you can change this codec to another codec form, and while constructing a video, so we are providing this here, and we have specified 50. So what we are saying that the right snap is true, and how many, we don't want all the frames when there is a bird. We don't want to take the snapshot of all the frames, we just want to take the snapshot of the 50 frames, so we can give some time difference in between them and just take those frames from over there. And we need to draw a circular box, as we have seen in the, when we were running that code, we have seen that we were getting some circular bounding boxes, right, and a rectangular box on top of that bird. So we want to do annotation, we want to perform annotation, so that is the reason we are saying annotate is equal to true. We do you want to display, yes, we have displayed it, and then the path where we want to save the file, and we have seen already the files were saved in at this folder, right. Now fps means what, the when we will be creating the video, how many in per second, how many frames should be there, so it will be a 20 frames per second. And when we are creating a new video from it, at least there should be a 20 frames. If there are no 20 frames, then there will be no, you can say, you will not be able to create a video. So that's what we are doing here, we have specified a frame. So that's what the JSON file is doing. This JSON file, now when we are running the code, this JSON file is a predefined parameters that we are passing. Okay, so that's what the conf.py file is helping us for doing. And let's see what is there in this our main function, main program. So if you wanna use the pi camera, like you kept a pi camera and then you want to record the live videos and store them, so you can just use this as python.bird.py, and don't specify this, and it directly the pi camera will be used, and the pi camera will record the frames, and then it will be stored. And if there is a bird or some kind of motion is going on over there, it will construct it will take the snapshot of those things. So we are using this helper function, that is a clip writer here, and we are using the confidentiality, that is a conf class we have defined. And we know that we are using this imult as a video stream, which help us to play with the getting video frames here. Then arg pass, so in arg, so we are giving a signal handler, that is if control C is there, please uh, this is the message we want to show. And when the files are stored, the files will be stored in which format, so it is given over there, right. Then we are in the argument pass, so we are giving the conf dash dash conf. So that's dash dash conf does what, it goes in this JSON file as we have seen, and takes all the predefined parameters that we want to pass when we are running this code, and we have already seen that, right. And then we are giving this conf args.conf, so we are reading them in a key value form, so that it will be stored inside this. Then we want to use a pi camera, and then we are giving a time sleep of there in between them is 3. If there is a video, then it will read the frames from the video. It will read the frames from the camera. If there is no video, it will start looking for whether there is any kind of camera available. That's what it is doing over here. So firstly it will check whether we have set this value for true. If it is true, then it will directly extract the frames from the camera. But if it is false, it will look for a video file, whether we have given a video file or not. So something like that. Okay, then we are defining, these are the different types of background subtractors that are available. There are many more background subtractors. You can go on the official website of OpenCV and you can see them. but I've specified this, that is CNT, GMG, emoji, and for this we were using emoji here, and then GOC and all. These are the different backgrounds of practice. In this chapter number 2 also you must have learned it in theory what our background subtractors are. And then just for the which background subtractors we are using, we are just specifying them over here, and then we need to specify the erode function and the dilation kernel uh, on we need to perform them. And then we are setting two counters. So firstly we are setting that when there will be a frames without motion, right? So we are setting the value as 0, and then we are setting the values of the snapshot to 0, because definitely initially we are not detecting any frame, so there will be no motion, so the value should be 0. And there will be no snapshot initially, so it should be set to 0. And when there will be a motion, the counter will run that, okay, number of frames that we are extracted, we need to store them. So once we have got that snapshot, after detection the motion, we need to store them. So here we are using the and will be increasing the counter over here, and we need to resize the subtractor now. Okay, after background subtraction we need to resize it, and we need to apply the foreground mask. So that's what we are doing here. We are getting the mask, and then on the mask we need to apply. So here we are doing this operation, this one. Okay, so this operation we are doing using this part over here, that we get a mask. Okay, where the part, okay, yeah. So for firstly we need to apply, we will be getting a mask over here like this, and then we are using this erode function and the dilation. And after getting this the we will be getting a smooth mask like this. Like we can see the error is the bird is there, and the other most of this noise is getting removed, right? When we will be creating a new video, we do not want this background, some background part is there, we completely want to remove this background, we just want this foreground. So that's what we are doing using this. And you can tune these parameters. Now you need to learn this, how to tune the parameters, which parameters we will tune. It is really important when you're learning computer vision and all, to understand which parameters are crucial and which parameters are not. So that's what we are doing over here. And then we are specifying the counters, uh, that when we extract the frames we are setting over here. And firstly we need to specify the circle is drawn, and the when we are in the foreground, uh, present, the object is present, so we want to draw a rectangular, right? So that's what we are specifying here. Okay, and then the timestamp we are giving, and if the motion of this is true, then we need to set the again the counter over here. And the annotation, uh, because the annotation for all the birds are changing, right? So when the birds is changing, so we need to draw a new rectangular, a new circle for different types of birds, because their shape is different, so their size is different, the mask will be different. Okay, so that's what we are updating over here. And the snapshot will be stored inside the folder that we have specified. And after specifying this we need to provide the path in which we are specifying, and we need to make a video, right? So we are using the codec that we have specified in the confidence file, that is the mpg codec. And then once we are done with that, we can just this kcw is our key write function, this keep that is key clip writer. So we are using it as kcw, and we just need to release it, right? So that's what we are doing here, and just stop this and the frames will be released. So what's there in the helper function? The helper function does so already we have seen this in the last session, how we need to read the frames, and then we need to write the frames. So we have already seen this. So this function does what is it will store the frames in the form of queue. And firstly we are setting a buffer size, and the buffer size will, firstly the buffer will be empty, and then we need to start. We will be getting the video writer file, and we will select the frames, then we will store the frames. And if there are frames are true, then we need to means what this key clip writer is doing, it means it's reading the video, and when there is a motion in that video, that frame will be sent here, and this frame will be stored inside a buffer. So that's what we are doing here. And if there is again another frame in which the motion is there, then we are updating the buffer, and we are continuously storing them in the form of a queue, so that we can have a chronology of that video, right? So to maintain the chronology, we are majorly using this helper function here. So firstly will start the getting the frames, then we need to write this frames, and lastly we need to make sure that the buffer is flushed out. So that's what we are doing over here. And this we are using this class in our main program. So that's it. I know there is there is lots of code in this practicals, but if you really want to understand uh, what is going on in this code and how all these functions are working, and so it is really important for you to play with this code. And yeah, that's it. I think so. Yeah, that's it.